Hi guys, today we're going to be going over the angle addition postulate. Now before we get started, we have to go ahead and identify what is the difference between a postulate and a theorem. Now a theorem is a mathematical statement that needs to be proven to be true using other mathematical statements. And a postulate is assumed to be true without the need of a proof. In other words, we don't need to use mathematical statements in order to accept the postulate as true. So hopefully this helps you later on once you get to geometry. So you are going to be required to learn or to know what is the difference between the theorem and a postulate. A theorem, again, you need to use mathematical statements to prove that it is true, and a postulate is something that we assume to be true. So there is no need to prove it. So as we can say, as a consensus, or the whole mathematicians assume that this is true, and therefore we do not need to prove it. So now what is the angle addition postulate? Definition: the sum of the parts is equal to the whole. So this is a simplified version of the definition of the angle addition postulate, but it makes sense. The sum of the parts is equal to the whole. In other words, if you have a whole, similar to the diagram that I have below, the whole would be the blue angle, the angle ABC. Now, if you guys remember, the vertex of the angle is going to be the letter in the middle. So angle ABC, the vertex is going to be B. So we're looking at the angle in blue. So angle ABC is the whole. And basically what you're doing is you're adding the smaller parts. If you add the two smaller parts, so 1 and 2, you get the bigger part. So if you add measurement of angle 1 plus measurement of angle 2, you're going to get what the measurement of the whole is, right? So in other words, if I use a protractor and I measure angle 1, so I measure angle 1, let's see, I measure angle 1, and then I measure angle 2, then in theory, I should get ABC, right? The measurement of angle 3 in this case. Now you can also go ahead and write this down as using this form of notation. So let's actually go ahead and do that. So let's go ahead and erase this so it makes more sense. So what is one of the smaller angles? So let's use that in green. One of the smaller angles is going to be this two rays, right? These two rays make this angle. Now let's call that one measurement of angle 1. So there's going to be, let's just use that green. So measurement of angle, and in this case I'm going to use the letters. So it's going to be A, B, D. Now why do I use B in the middle? Why didn't I write measurement of angle, let's see, for example, BAD? Well, the reason why, again, is because B is the vertex of this angle. So it doesn't make sense for me to put A in the middle. You always have to put the vertex in the middle. So the vertex in this case is B, so that's what I have to write down. Now let's look at the second angle. So the second angle is going to be this one, right? And now for that angle, what should I use? So what are the letters that I have to use? Well, one possible combination could be, for example, if I'm starting from the top, it could be measurement of angle DBC. Now, another, or someone else could probably say measurement of angle CBD. So both of these are true because if you notice, B is still in the center. So you're using the same three letters. We have D, B, and C. And in this case, interchanging C with D does not change the angle. We're still talking about this angle. But the only thing that does matter is that the B needs to be in the middle. So we can leave it like this. And now the larger angle, or the whole, which is the blue one, in this case is going to be measurement of angle ABC. Now I could have also used measurement of angle CBA, but I could have not used angle, for example, CAB. This one does not work. Why? Because B needs to be in the center. All right, so now that we learned the notation, let's go over some examples. So again, basically what we're saying is that when we add the parts, it has to be equal to the whole. So let's give a quick example here. So let's say that the blue angle is a measure of 120 degrees. And then let's say that I use a protractor and I measure this smaller angle and I get, for example, 40. Well, having these two measures, I can actually figure out what the last angle is. So this third angle, what should that angle be? Well, let's think back to our definition. The sum of the parts is equal to the whole. So in other words, the two smaller ones has to add up to the larger one. So 40 plus blank is equal to 120. What should blank be? Well, blank should be 80, right? So that means that this one is 80 degrees because 40 plus 80 is equal to 120, which is the larger one. Hope this is making sense. And if it's not, you guys can go ahead and replay this several times before you guys move on to the examples. Now let's go over two examples. So example 1, let's call this one 1. Let me clear that up. All right, so it's going to be example 1. It says find measurement of angle RSP. So RSP, let's make that in green. RSP is going to be this one, right? RSP. So we're looking for that angle. Given that PST is 159. PST. So we start with P, and then we use, let's make that gray. We start P, we go to S, and then T. So we're talking about this angle. So this one is 159. And then we don't know what this one is, but we are given something else, that RST is 179. So RST is from here all the way to here. So in this case, which one is the whole? Which one is the larger angle? So the largest angle is RST, right? So RST is 179. So that's going to be my whole. And you should always try to find the largest angle first. So this one's going to be 179 just because it makes it easier once you write it down. So this one's 179, and then you add the two smaller ones. So PST is 159, and we don't know what this angle is, right? So we're looking for this angle. But I do know that when I add that angle, I get 179. So in this case, I used a question mark just to make it simple on myself, but you could have also used X. So now to solve this, you can think about one way to do it is 159 plus what is 179. So if you said 20, you're correct, right? Because 159 plus 20 is equal to 179. Another way that you could have done it is subtract 159 from both sides. And you'll notice that you get the same answer. So you get 20. Now let's go over a slightly harder example. So this one is going to be 2. Example 2. And in this case, let's see, we're looking for X. If measurement of UTC, so let's use red, UTC is equal to 6X plus 1. So now UTC, so is that the whole? So remember, we have 3 angles. Measurement of angle 1. Well, let's actually make that in white so it makes more sense. Measurement of angle 1 plus measurement of angle 2 is equal to measurement of angle 3, or measurement of the larger angle. So in this case, the larger angle, which I'm going to mark in blue, is this one, right? So UTC is not that angle, so it has to be either measurement of angle 1 or measurement of angle 2. It doesn't really matter which one, because 1 plus 2 is the same thing as 2 plus 1, right? So changing the order does not matter. So in this case, I'm going to let it be measurement of angle 1. So that's going to be, I'll make this one 1, and I'll make the other one 2. So the red one is going to be 1, so it's going to be 6x plus 1. And then the green one, let's see, well, CTS, so let's erase this. CTS, so we start with C. T is right here, so CTS, so that's going to be my angle 2. So angle 2 plus angle 2, which is this one, and that's 10x plus 10, and then it's equal to, well, the larger one, right? So the larger one, let's see, so this one was 2. The larger one, it's telling you that UTS is 123. So let's see, UTS, this is the larger one, right? So this larger one is 123. And then from here, all you have to do is solve for x. So you solve for x by combining like terms. Remember, because this 6x and this 10x are both on the left-hand side of the equation, all you have to do is combine them. So you have 6x plus 10, that's going to be 16x. So you have 16x, and then you add the 1 and the 10, so that's going to be plus 11, and it's going to be equal to 123. Now, another way that you could have thought about this is the following way. You could have also written it this way, so just moving them around. So 6x plus 10x plus 1 plus 10 is equal to 123. So all I did was move them around, similar to what I said before. 1 plus 2 is the same thing as 2 plus 1, so moving them around does not change anything. So now there's going to be 16x plus 11 is equal to 123, which is the same thing that we got before. And then here you have to use algebra, basically. You have to use the same methods we've been using before. So inverse operations to solve for x. So we subtract 11 from both sides because we want to isolate the variable. So that's going to give me 1, let's see, what is that? 112, and it's going to be 16x. And then from here, you divide by 16. 112 divided by 16. Let's see, what would that be? Let's see. So x is equal to 7. And that's pretty much it. Now, I'm going to be posting other 2 examples in another video, but that's it for this video.